Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I have explained the 10 questions which were there in the exercise part of this particular gravitation chapter, which is there in 9th standard science subject. So now in this particular video, we will further discuss the next exercise questions which are there in this exercise. Coming to the 11th question in this particular exercise, here they have asked why will a sheet of paper fall slower than that is crumpled into a ball. So here basically if you throw a sheet of paper like this, so in my previous questions I have given answer that inside a vacuum, if you drop a heavy object and a light object, for example an iron ball and a bird's feather, then both reach same time to the ground, but their vacuum will be there, and because acceleration due to gravity is same in that particular place, hence both the object will fall at a time to the ground. But here they are not asking inside vacuum. So in this question, in normal atmosphere, if you drop a particular paper and if you crumple this paper into a ball like this, so let's say paper is crumpled into a ball like this, and both of them, if they are dropped towards earth's surface, then you can see that this particular crumpled paper will fall immediately onto the earth's surface, but this paper will float around the air and slowly it will fall onto this particular earth surface. So why this is happening? Why the same paper which is having same mass, when it is crumpled, it is taking less time to reach the earth surface, but when it was a paper, then it was taking more time to reach the earth surface. Because here, since paper, when it is in its normal shape, at that time it has covered more surface area in the atmosphere. So that means more air molecules will be hitting to this particular paper. That means more air resistance this particular paper will experience. So this sheet of paper experience more air resistance. So air resistance is more for this particular piece of paper, and for this air resistance is less. So that's why this particular crumpled paper, immediately it fall onto the earth surface, but paper takes little time to reach the earth surface because of air resistance. So coming to the 12th question, here there is a 10 kg massed object. So there is an object which has mass equal to 10 kg. Now you have to calculate weight of this particular object on earth and weight of the same object on moon surface. So one hint they have given in this particular question, that is weight on moon is 1/6 of the weight on earth. So now first we have to calculate what will be the weight of this particular object on earth surface. So we know the formula for weight is mass times acceleration due to gravity of that particular planet. So now we are considering weight of this particular object on earth. So acceleration due to gravity will be of earth surface. So mge. So ge is the acceleration due to gravity of earth. So mass is 10 kg. So mass into acceleration due to gravity of earth is 9.8 meter per second square. So kg is also SI unit, meter per second square is also SI unit. So directly I have substituted 10 into 9.8 in the place of m and g. Now WE, that is weight on earth surface, is equal to 10 into 9.8, that is 98 kg meter per second square. Or simply, since this is weight is a force, we can give the SI unit Newton. So capital N. So now to calculate weight of this particular object on moon surface, we have to just multiply 1/6 with the weight of this particular object on earth surface. So we are getting 98 Newton as weight of this particular object on earth surface. So 1/6 into WE is 98/6. So if you do 98/6, you will get answer as 6 ones are 6, 6 ones are 6, so 3 will be remaining, 38 is there, so 6 6s are 36, so 2 will be remaining, 26 3s are, so now you have to take point, so 6 3s are 18, so 2 again will be remaining, so 3 goes on like this. So now weight of this particular object on moon's surface is approximately equal to 16.33 Newton. So weight of this particular object on Earth's surface was 98 Newton. If the same object is taken onto the moon's surface, then the weight of this object on moon's surface will be 16.33 Newton. Coming to the 13th question, here simply a ball has been thrown against gravity vertically upwards. So now you have to calculate what will be the maximum height this particular ball reaches to, and you have to calculate how much time this particular ball take to reach this maximum height and to reach back to the Earth's surface. So you have to tell the total time, and also you have to tell the maximum height this particular ball has reached. So whenever a particular object is thrown vertically upwards against gravity, then that particular object with the force given, it overcomes the gravitational force and it starts moving vertically upwards. But because gravitational force will be constantly pulling downwards, the force goes on reducing and it reaches a particular maximum height, and after that, due to gravitational force influence, it falls back to the Earth's surface. So that means here when it reaches maximum height, final velocity or final speed is 0. When this particular ball was launched from Earth's surface, its initial velocity was equal to 49 meter per second, which is given in this particular question. So now we have initial speed, that is 49 meter per second, and final speed is equal to 0. Based on this, you have to calculate the maximum height. So if you consider third equation of motion, that is v square is equal to u square plus 2as, here in the place of acceleration we have to take the acceleration due to gravity. And always remember, here object is moving in the opposite direction to the gravitational force. So that's why in the place of a we have to take minus g. So v square is equal to u square plus 2 minus g into s. So in this case, s is height, h. V square is equal to u square plus 2 of minus g into h will be there. So here v square, v is anyway 0. So that's why v square becomes 0 is equal to u square minus 2gh will be remaining. So this minus 2gh you can bring to LHS. So plus 2gh is equal to u square. So now you can keep h on LHS, you can bring 2g to RHS. So h will be equal to u square divided by 2 into g. So u square is 49 into 49 because u is 49 divided by 2 into 9.8 meter per second. So 49 into 49 divided by 2 into 9.8 will give you 122.5 meter. So this is the first question in this 13th question. So now you have find out height as 122.5 meter. Now you have to calculate, in the second question you have to calculate total time. So that means here total time is the time where ball has reached that particular maximum height and it came back onto Earth's surface. So t plus t you have to take. So that will be your total time. So the total time is equal to t plus t, that is equal to 2t. So what is this t? This t you can calculate from equation of motion itself. So first equation of motion tells us v is equal to u plus at. So here in the place of a I can substitute minus g, so u minus gt. So this minus gt you can bring to LHS. Before doing that, we all know v is 0. So that means 0 is equal to u minus gt. So if you bring gt to LHS, it will be gt is equal to plus gt is equal to u. So now we have gt is equal to u. So t you can keep in LHS and this g you can bring to RHS. So t is equal to u divided by g. So u is 49 divided by g. G is 9.8. So now you can calculate this. 49 divided by 9.8 is equal to 5 seconds. So 49 divided by 9.8 is 5 seconds. So now you have got time. So the total time is equal to 2t. So 2t means 2 into 5, that is 10 seconds. So total time for this object to reach back Earth's surface is 10 seconds. So this is the answer for second question in 13th question. Coming to the 14th question, there is a particular tower like this. So from the top of this particular tower, a stone has been released. So for example, if a person is standing on this tower and he is releasing this particular stone, and if this stone is released from the top of this tower to Earth's surface, so you have to calculate the final velocity just before the stone reaches the Earth's surface. So just before it reaching the Earth's surface, what was its final velocity? That you have to calculate in this particular 14th question. So the data which they have given here is the height of this particular tower is 19.6 meter, and you have to calculate the final velocity. Now here the stone was just released from the top of tower. That means initial speed of this stone is 0 and final speed just before it reaches Earth's surface is, we have to calculate. So if you use the first equation of motion, then v is equal to u plus at is there. But here time comes into picture, we don't know what is the time. So we can use the third equation of motion, that is v square is equal to u square plus 2as. So here a is equal to g. In previous question I told a is equal to minus g because the ball was traveling against the gravitational force. So that's why acceleration due to gravity, I took that as negative. But here this particular stone is traveling with the influence of gravitational force towards the Earth's surface. So that means here g is plus g only. So a is equal to plus g. V square is equal to u square plus 2gs. So here s is nothing but height. So v square is equal to u square plus 2gh. So v square we have to calculate. U square, u is nothing but 0. So 0 plus 2 into 9.8 into what is the height of the building. So v square is equal to 9.8 into 2 into 19.6. So you will be getting 384.16 as your answer. So now v is equal to, here square root of 384.16 you can take. So here plus or minus should come, but here velocity, the final speed is positive term, hence we are just taking the positive value of this particular square root. So plus square root 384.16. So now if you take square root of 384.16, you will get the value for this particular final speed. So that is equal to 19.6. So 19.6 meter per second is the final velocity this particular stone has reached. So just before reaching Earth's surface, the final velocity with which this stone was traveling was 19.6 meter per second. So coming to the 15th question, 15th question is more or less similar to the 13th question. Here also a particular stone is thrown upwards, vertically upwards. You have to calculate the maximum height and you have to calculate the average distance and the displacement of this particular stone in this particular question. So initial velocity of this stone was 40 meter per second, which is given in this question. So final velocity, obviously it will be 0. Now we have to calculate the maximum height. So you can use the third equation, that is u square. V square is equal to u square plus 2 h will be there. So in the place of s, that is distance, I am writing h, that is the height. So in the place of a, I can write minus g because it is traveling vertically upwards against gravitational force. So that's why I am taking minus g. So V square is equal to U square minus 2GH. So now you have to calculate the maximum height. So V is 0. So 0 is equal to U square minus 2GH. 2GH if you bring to LHS, it is 2GH is equal to U square. Now you have got 2GH is equal to U square. 2G if you bring to RHS, it will become U square divided by 2G. So H height is equal to U square. U square is 40 meter per second. So 40 into 40 will be there in the numerator. In the denominator, here they are telling to consider acceleration due to gravity of Earth as 10 meter per second square. So whenever they tell you to take 10 as the acceleration due to gravity, you should take it. Only when they are not mentioning any value for acceleration due to gravity in the question, then you have to take 9.8 only. You should not take 10. But in this question, they have specifically mentioned to take 10 meter per second square as acceleration due to gravity. So we can directly take 10. So 2 into 10 will be there in the denominator. So here 0, 0 gets cancelled with each other. 2 ones are 2, 2s are 4. So 40 into 2 is 80. So 80 meter is the maximum height. Now what is the distance traveled by this particular stone? So distance, the total distance. So the total distance traveled by this stone will be equal to 2 times the height, because it has reached the maximum height and it has, because of the gravitational force, that stone falls back to the earth's surface. So the total distance covered by the stone will be 2 times the height. So 2 times the height, that is 2 into 80. So 2 into 80 is 160 meter. Now if you want to calculate, so this is distance. Now if you want to calculate the displacement, then, so now if you want to calculate total displacement, here the total displacement is just 0. Because this stone has started from its initial position, it has reached the maximum height. Because it is traveling vertically upwards, it will fall vertically downwards only, and it will reach the same initial position. So that means the stone was exactly vertically traveling upwards. If it is traveling like that, then it will follow the same path and reach its initial position. So what is the displacement? Displacement is 0, because it has reached its initial position only. So that's why total displacement is 0. Total distance, or the average distance, is 160 meter, and the maximum height this stone has reached is 80 meter. In 16th question, you have to find the gravitational force between Earth and Sun. So the gravitational force between Earth and Sun you have to calculate in this particular 16th question. So in order to calculate gravitational force, you can take the universal law of gravitation, that is F is equal to universal gravitational constant G into mass m1, that is here mass of Earth and mass of Sun, divided by distance square. So here distance between Earth and Sun you have to take. So now force is equal to 6.673 into 10 power minus 11. So mass of Earth they have given here as 6 into 10 power 24 kg. So 6 into 10 power 24 into mass of Sun they have given as 2 into 10 power 30 kg. So 2 into 10 power 30 divided by distance between Earth and Sun they have given as 1.5 into 10 power 11 meter. So 1.5 into 10 power 11 meter whole square. So now we can calculate this force by solving this. So here you can see 10 power minus 11 is there, 10 power 24 is there, 10 power 30 is there. So bases are same, so you can add the power. So here 6.673 will be there as it is, into 6 into 2 will be there as it is, into 10 power minus 11 plus 24 plus 30 will be there, divided by d square, that is 1.5 square into 10 power 11 is there. So 11 into 2 is 22. So here I have just taken square of 1.5 into 10 power 11. So that is 1.5 square into 10 power 22, because 11 into 2 is 22. So now we have this particular equation. So F is equal to 6.673 into 6 into 2 is 12 divided by 1.5 into 1.5. So 1.15 into 15. So 15 into 15 is 225. So after two decimals you can put decimal point. So 2.25 into this 10 power 22, if you take to numerator it will be 10 power minus 22. So here if you solve this, minus 11 plus 24 will be plus 13 plus 13 plus 30 will be plus 43 into 10 power minus 22. Now you can, here also bases are same, so you can add the exponents. So 43 minus 22 is, so 43 minus 22 is 21. So 6.673 into 12 divided by 2.25 into 10 power 21. So now if you calculate this, you will get 6.673 into 12. So 6.673 into 12 divided by 2.25 into 10 power 21 is there. So F is equal to, so 35.59 into 10 power 21 Newton. So now the force is equal to 3.5. This 59 can be round off to 6. So 3.56. So one decimal I have bought. So this particular decimal point, after one decimal I have bought here. So you can add one power here. So 10 power 22 Newton. So 3.56 into 10 power 22 Newton is the gravitational force between Earth and Sun. So this is all there in this particular chapter. Like this, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.